When it comes to choosing a screen filter, there are several things you need to know about your water system to ensure that you select the right filter and screen size. You don't want to oversize or undersize your filter, as this means you may have to flush the filter more often and cause the system to inefficiently filter the sediment and debris, resulting in unclean water. There are 4 things you need to know in order to choose the correct size of filter. 1. The filtration requirements. 2. The flow rate of the system. 3. The maximum pressure loss. And 4. The particle load of the water you're filtering. You can use these pieces of information to specify the 2 options on the filter, the screen mesh and size of the inlet and outlet. Filtration requirements are usually expressed in mesh size, which means the number of openings per linear inch in the screen. The TwistIIClean offers 5 different filter mesh sizes. 30 mesh screens are sufficient for large orifice impact sprinklers, offering protection from large pebble-sized debris. 60 mesh screens are typically used for spray and rotor sprinklers, offering protection from coarse sand particles. 100 mesh screens filter out coarse sand particles and are common for residential use, water treatment pre-filtration, well water systems, and culinary water. 140 mesh screens are for systems using more sensitive equipment like fine mist spray nozzles and power washers that need silt and fine sand filtered out of the water that would otherwise clog up the nozzles. 200 mesh screens are ideal for drip irrigation or as a pre-filter for very fine cartridges. For instance, adding a 200 mesh TwistIIClean filter before a charcoal filter will reduce the wear and tear on the charcoal filter, prolonging its life and saving you money. If you're planning filtration for a system being installed, flow rate information is often available based on the water meter size or pump information. If you're working with an existing system, you can test the water flow using a bucket to measure gallons of flow and a timer to measure the flow time to determine the flow rate. Here's how to test a residential system by timing how long it takes to fill a 5-gallon bucket. Make sure nothing else in the water system is running at the moment. Then turn the water on to fill the bucket and time how long it takes to fill. If it takes 35 seconds to fill, divide the 5 gallons by 35 seconds, then multiply by 60 to convert to minutes. You'll see that the flow rate is 8.6 gallons per minute. For a well system, turn off all the water running in the system. Then start filling your bucket at the spigot. Fill it until you hear the well kick on, then turn off the spigot and time how long it takes for the well to kick off again. Divide the number of gallons collected, let's say 27.5, by the number of minutes it took the well to replenish the system, let's say 2.5 minutes, to get the true flow rate. In this example, it would be 11 gallons per minute. Combined with flow rate, you'll see the maximum allowable pressure loss to select a filter size. If you know what water pressure is available at the device without the filter, and you know the requirements for optimal functioning of the device, you can easily calculate the maximum allowable pressure loss. When sizing the filter, locate the flow rate at the bottom of the sizing chart. Then follow that line to see what the pressure loss is for each filter size at that flow rate. For example, if you have a flow rate of 11 GPM, you can see that 3/4 inch TwistIIClean will lose about 2.5 psi, and the 1 inch will only lose about 1 psi. Depending on your system's needs, the 3/4 inch will probably be a fine choice for your application. If you've got a flow rate of 60 gallons per minute, you can see that the 2-inch TwistIIClean loses less than 2 psi, while the 1.5 inch loses over 5 psi. In this scenario, you might want to go with the larger option. Note that these values are based on clean water. You'll also need to account for particle load in sizing your filter. For water supplies with high particle loads, a choice based solely on flow rate and pressure loss may not be sufficient to address the filtration needs of the system. There are several things you can do to address this problem. You can choose a bigger filter to catch more debris with a screen that has a greater surface area. Another option is to run 2 filters in a row. Put a coarser mesh in front of a finer mesh. This 2-step filtering process picks up some of the burden of the larger particles first and eases the burden of the finer filter downstream. You can also run 2 filters in parallel, splitting the main line into 2 lines with a TwistIIClean on each side, which then comes back together to one line. This divides the filtering load in half, doubling the surface area of screens that filter and extending the time between cleanings. Finally, for extremely sandy water, you can upgrade to a sand separator, installing it before the TwistIIClean, using the two filters in conjunction. Knowing the requirements for your system will help you choose the right TwistIIClean for your needs, assuring a long life of easy maintenance and dependable protection for your water system.